Hello coders, welcome to my channel Radhe Radhe. This is the last lecture of our sliding window playlist. In this, we are going to discuss the two questions as I usually discuss the two questions. The first one is from medium, and the second question is from the hard of the lead code. So let's start. We have the question name is maximum number of vowels in a substring of given length. So I am most of the I have discussed most of the question in which the integers array was integer and we have to use the sliding window concept. Now in this question we are going to deal with the strings and how we how we use a sliding window concept in our string. It is very much similar to that. If you know about the string, you can get it very easily. So yeah, let's talk about what question is saying. We have given a string and an integer k. Return the maximum number of vowels letter in any substring of s with length k, and the vowels are a, e, I, o, u. So the question is trying to say us that we have to find a substring of length k. We have to find a substring of length k, and we have to check the maximum number of vowels which occur in between. Like what the number of maximum number of vowels which are in between, we have to return that number of vowels as our answer. Like you can see, and vowels, I know you all know that. So like you can see, we have given in the test cases we have given string a b c I d e f. Now k equals to 3, so we have to check for each substring of length k. Like you can see, if we check ABC, there is no vowels, so vowel will be 0 here. Same way we will try for all the substring. Now we will get answer. We will get III, which contain three vowels as a and this substring. So we will return three as because three is maximum. So we will return three. Same way, if you see, you will get length of 2 ei, it will be ei, it will be io, it will be ou, but the maximum will be 2 only, so we will return 2. And the same way you will see that here for length 3 we have lead code in, we consider 2 as a maximum number of vowels, because in lee there is only two vowels, in eet there is only two vowels, in ode there is only two vowels, so at most it is only 2 as your answer we will get. So now let's start how our question, how we will solve this question. So let me open my Jamboard first. So yeah, uh, we have given A, A, B, C, I, 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 and D, E, F. Now what is the brute force that coming in our mind is that we will generate all the substring, and then we'll check, and then we will count the number of vowels, and yeah, and then we return that. So now if we talk about the time complexity, like we have generating all the subarrays, so it will take over fairly square time. Now we are also calculating the number of i's or number of that is vowels, that will also take some time. So over square is not a good solution. So will we try to avoid that? We will not use this, because as you can see, our constant is very much high, and it will generally with the constant 10 to the power 5, we don't use over n square solution, because it will become 10 to the power 10, which and usually, as I have said in many of my lectures, that our program is run only if our time complexity is in lesser than 10 to the power 8. So now the what is the optimized solution? The optimized solution, like as we are discussing sliding window, so obviously we will use a sliding window concept. And as I have taught many times that if we need to generate any sub arrays, we will always try to solve it by sliding window. Now, DEF I have given. So what I'll do, I'll just the basic standard template of our sliding window. We will take I here, j will be here, and a count variable which will take care about the number of vowels that is in between that substring. Now we'll check if a is any vowel. No, not right now. No, it is not. So we will not increase. We will just move our j because our length is smaller than k, because we have given the length as well, and it is the fixed. I missed this. It is a fixed sliding window problem. And again we'll check if b is any vowel. No, we will move that. Again we'll check is c is any vowel. No. Now, before moving that, we will check that what is the length. Length is k, and if we will move our j pointer, then the length will exceed. So we will move our j pointer. Now length will exceed. So what we'll do, we will just move our I. But to move our I, we have to take care about that. If there is there any their vowels was uh, at I position, so that we can remove that from our the count. And we will as I'm doing many like in some checking the number of arrays with sum equals to k. So in this what we'll do, we will, before moving the window, we will remove that sum from our that number from our sum. The same thing we will do, we'll check is this is vowel. No, not it is not. So we will not do anything with the count, we will just move it. We again will check. No, we will just move it. Now what we'll do, now what we'll do, simply and the size becomes smaller than k, so we will again add new elements in our sub arrays and check it is, if it is vowel, then we will count, increase our count. Yes, right now it is, yes, it is a vowel, so we will do count plus plus. And doing all the drawing, if you dry run, you will get that this is the only III which contain number 3 as the maximum answer. So the same thing we have done here. I'll just so let's move to our code. I'll taking answer to, because we need maximum one, so we are taking answer to which to keep track of the maximum vowels in all the substring. Now there's a count which check the number of count in that particular substring, and then the 2 pointer ij. And as our loop always run from j smaller than the array, or here it is string to string, length of the string. Now we'll check if the number, if the current character is any vowel. If yes, then we will increase our count, and then we'll check that if the length is smaller than k, though it means we need more element. So for getting more element, we just move j plus plus. Else if we'll use else if and check if it is equals to k. So okay, we get our answer, because we need only subarray of k length. So we will just take care about our current count, and we put in our answer. And before moving, what we'll do, we will check that if the ith, that is the starting point, starting of that substring is containing any vowels, so we will remove that vowels by doing count minus minus, and then we'll just increase our I plus plus, doing to move our window, and j plus plus, and then return our answer. So this is a simple sliding window questions. Sliding system is standard hai. This one is standard one. I don't think that you will face any difficulty while solving this one. Now, if we talk about the time complexity, it's taking while only, while loop to often, and the space complexity is also like we haven't take any space, to it is O of 1. Now, if we submit the code, it will pass all our test cases. So now, I think I have discussed all the thing about this question, and hope you understand. Now let's move to the second question, that is the hard marked as hard in our lead code. Now, now this is, I think this is the first question, a hard question that I'm discussing. but is it just marks hard. If you learn, it is very easy to solve. So now let's start. Count Subarray with score less than n k. The score of an array is defined as the product of its sum and its length. Um, so what the question is saying, that to calculate the score of any number, what we'll do, we will just take the sum of all these elements on that particular subarray, and then we will multiply that with the length of that subarray. So here, if we are taking this whole as our subarray, so we will add all this element, and then we'll multiply with its length, and the 75 is the score. So simple thing is doing now. This is the way to calculate the score. Now the actual question is giving saying that we have given a positive integer array nums and integer k. Return the number of non-empty subarray of num whose score is strictly less than k. So it means the question is trying to say that we have to check, we have to count the number of subarrays whose score is strictly less than k, means smaller than k, and equals to or greater than is not added in our answer. So we need the subarray whose score is less than k. So simple, I think you understand. It is simple, like sum of subarrays smaller than k, number of subarrays smaller than k. But what is the restriction here? We have to not we have to do sum. We have to take care about the score, and in the score we just need to multiply the length. The small changes there, like you can see here is here's a six subarrays whose whose score is less than k, like here 2. So we multiply with sum all the element. Here is only 1 to 2 into length is 1 equals to 2, and 2 is more than 10, so we are including this in our answer. Same way we all are doing, and in in 2 1 we are summing their element, we are into with their length, and 6 is the answer, so which is smaller than k. So that's why 6 1 2 3 4 5 6 is the six number of subarrays are there whose score is less than k. Same way we have the same thing has done here. So now let's see how we'll solve this question. A very easy question. Let's take sorry 2 1 4 3 5, and we have given k as 10, I think. Yes, 10. Now what we'll do, we will take a two pointer, same thing what we are doing till now, and then we will like here the length is not given, so it means it is the variable size subarrays question, variable size sliding window question. So now after moving the subarray, if you moving the window, there is a condition, always a condition required. So what is the condition here? Like length is not given, so we don't took length. So here the condition is score is strictly less than k. So what will check, if the score is become greater or equals to k, then this is a condition of our moving our window. So the same thing we will do to move our window. Now here we check 2, and 2 into length is 1 1, and it is 2, and our k is 10, this is smaller than, so we will include in our answer. Okay, and then we will move this, we will again check, we will move this, we will again check. Now I think if we come to 214, it exceed our condition. If it exceed, what we'll do, before moving our window, we will subtract this particular element from our sum, and then we will move, and we again, if it exceed, so we will just do subtract that particular some particular element from our sum, and then we will move. Now there's a one question arises that we don't only need to calculate the sum, we also need to multiply that particular length of that subarray. So what we'll do, we will not include this, we will not multiply our length in the sum directly. What we'll do, we will multiply if in our check condition, like if we write the condition if, then we in the if condition we will multiply. Means what I mean to say that we will just take care about the sum. We will just take care about the sum, and in the if condition we will multiply that length. the length will be here, then we multiply with sum, and we'll check is it smaller or greater or what. So so now we have not multiplied that in our sum. So when we will move our window, we will don't need to divide that length also. Then we don't need to. We just need to subtract the element from our sum. Same way, we will do. We will check for this. 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 Now, I think you understand. Let's jump to our code. So what we have done like here the long we are using because the calculation might be very big. So that's why we are using long. We are taking answer and sum. Answer will take care about the number of count the number of subarrays, and our sum is for summing all the elements. Now simple we are using while loop and checking the sum of numbers j. We are checking now. Sum we have done sum now. What is the breaking condition? Breaking condition is that if the sum into length will be greater than equals to k, so it is a breaking condition. We need to move that window. So before moving, we will need to subtract that from our sum, and then we will move it. So simple we are doing while. We are using while because until the score is greater than or equals to k, we have to move that window. Else if this is not coming, this condition is not valid, else we are just counting the number of subarrays and doing j plus plus, and then returning our as an answer. Now j minus I plus 1, I think you understand. I have told in many of the lecture like to count the number of subarrays from here to here, we don't need to answer all, we don't need to increase all by doing checking all. We just need to do j minus I plus 1. It will give all the number of subarrays here which are valid. So if we submit our code, it will submit all our test cases. Now, yeah, you can see. So now if we talk about the time complexity, one while loop. So that's why O of n, and no space. That's why O of 1. So I think you understand this question. This is marked hard, but it is very easy to solve. Now, this is the last playlist, last video of our sliding window playlist. Now, from the next lecture, I'm going to start the hashing. Hashing is also one of the most popular DSA, and many of the product-based company or startups usually ask question from it. So I think I will start that. Now I hope you understand my solution, and hope you like my video. So if you like it, please like, share, and subscribe. Thank you.